is Algebra 2, Lesson 64. We'll be talking about complex fractions and complex numbers. And we're starting on page 271. Complex fractions are any fraction that contains more than one fraction line. This one actually contains 3. We can simplify this by finding a common denominator in the numbers excuse me, of the numerator of the complex fraction. So we're just going to start with this top, and we're going to say that the common denominator is going to be b. So it'll be 1b plus xb over b, which equals 1 plus xb over b. Okay, we can put this back in here and say 1 plus xb over b all over a b. This is a fairly simple complex fraction. For a complex fraction, we're going to invert this guy and multiply him times the top and the bottom. Okay, this one cancels, and this leaves us with 1 plus xb over b times b over a. The b's cancel, and we are left with 1 plus xb over a. And that's your answer. That wasn't too hard. This one's a little more involved. Write the following as a simple fraction. A plus 1 over 1 plus b plus x. Okay, we're going to start by simplifying the second term and ignoring this a for a moment. So starting from here, we have 1 over 1 plus b plus x. So let's find a common denominator here. It would be b. So this is going to equal 1 over b plus xb over b, which equals 1 over 1 plus xb over b. Okay? Now we're going to multiply the top and bottom times times this inverted. So b over 1 plus xb, and the top times 1 over 1 plus xb. These guys cancel, so we have 1 times b over 1 plus xb. So that's going to be what we have here. Okay? So this is the second term simplified. Now we need to go back and add the a. So we have a plus b over 1 plus xb. And now we need to find another common denominator. So we're going to do a times 1 plus xb plus b all over 1 plus xb. And now we multiply it through, so we get a plus, I'm going to switch these so they're in order, a, b, x, plus b, all over 1 plus bx. Okay? That's ugly but doable. Let's try another one. Write a over x plus 4 over 1 plus bx as a simple fraction. Okay, we're going to start with this crazy second term again. So we have 4 over 1 plus bx. And the denominator, let's find a common denominator. So that will be x over x plus b over x. So that's going to equal x plus b over x. Okay, and the 4 is still here. Now we're going to multiply the top and bottom by this inverted. These cancel. And we have 4x over x plus b. Okay, now we're going to put the first term back into the equation. So we have a over x plus, whoops, I totally missed that line. Alright, well, I'll just imagine that they're on the same line. Sorry about that. That's what I get for writing without looking. Okay, so now we need to find another common denominator. So we'll have a times x plus b over x times x plus b plus 4x squared over x times x plus b. Okay, we've done this kind of stuff many, many times. We have ax plus ab plus 4x squared all over, pull the stuff out of the denominator, out of the parentheses, x squared plus bx. And that's your answer. Okay, now we're going to talk about complex numbers. We remember that any number that can be graphed on a number line is a real number. So negative 2 times the square root of 2 is very close to the square root is very close to negative 3. So we can graph that. 2 times the square root of 2 is still very close to 3, so we can graph that. Square roots of negative numbers, or numbers that contain i's, which is the square root of negative 1, cannot be graphed. So we call these imaginary numbers. That would be 2i, or the square root of negative 3, or the square root of negative 1, or the square root of 142, or I times the square root of 7. These are all imaginary numbers. If a number has a real part and an imaginary part, we call that a complex number. So negative 4 plus 2i, 5 minus 3i, 7 to the square root of 7 times the square root of 2 plus 6i. These are all complex numbers. We put these in standard form, which is a, which would be the real number, plus bi, which would be the imaginary number. So they're always going to go in this order. Okay? So here's our first example. Excuse me. Simplify the square root of negative 2 times the square root of negative 3. We're going to begin with Euler's notation. The square root of negative 2 is the same as I times the square root of 2. So we're going to multiply this times I times the square root of 3. Okay? Now we're going to multiply these together and we're going to get I squared times the square root of 6. I squared is the same as negative 1 because I equals the square root of negative 1. So we can also say I squared times the square root of 6 is the same as the negative square root of 6. Okay? That would be your answer. Here's a pretty one. Let's take this in parts. First we're going to look at this first term. 4i cubed is the same as 4 times I squared times I, right? And we know that I squared is minus 1. So this is the same as 4 times negative 1 times I, which equals negative 4i. Okay? Let's look at the second term. We have minus 2i to the 4th. I to the 4th is the same as I squared times I squared. So that's going to equal negative 2 times negative 1 times negative 1. We have a negative and another negative, so those two cancel and make a positive, times another negative, So this is going to equal negative 2. We have plus 2 times the square root of negative 9. We use Euler's notation. Pull the negative 1 out of here because this is the same thing as 2 times minus 1 times 9, right? So this is going to be 2i times the square root of 9, which equals 2i times 3, which equals 6i. Okay? Now we have the negative square root of 3 times the square root of negative 3. Sorry, the square root of negative 3 times the square root of negative 3. Okay, we're going to use Euler's principle or Euler's notation again and say this is I times the square root of 3 times I times the square root of 3. I times I equals negative 1. The square root of 3 times the square root of 3 equals 3. So this is going to equal negative 3. Okay, now we can take all 4 of these terms and plug them back into each other. So we have minus 4i, minus 2, positive 6i, and minus 3. We put like terms together. Negative 4i and 6i are going to make 2i. Negative 2 and negative 3 makes a negative 5. And now we need to put this into standard form. So it would be negative 5 plus 2i. And that would be your answer. This is going to be one of those problems where it's very important that you show your work so you don't get lost. So this is going to take you more than just one line, and that's okay. Use lots of paper. They're planting more trees. It'll be fine. Okay, we're going to multiply 4 plus 2i times 3 minus 2i. And they would like us to try this vertically this time. So 4 plus 2i times 3 minus 2i. We're going to multiply those. So 2i times 2i, negative 2i times 2i will be negative 4i squared. Negative 2i times 8 is negative 8i. 3 times 2i is 6i. 3 times 4 is 12. Add these together. We have negative 4i minus 2i and 12. Oop, and this is an I squared. Okay, I squared equals negative 1. So this is really negative 4 times negative 1. Okay, now we're going to simplify and put, this will be 4. So 12 plus 4 minus 2i equals 16 minus 2i. And that's your answer. Okay, let's try this one. This time we're going to do it horizontally. 5i minus 2, 4 plus 3i. And we're going to do our friend FOIL, so we have 20i plus 15i squared minus 8 minus 6i. Put all the like terms together. We have 15i squared plus 14i minus 8. I squared equals negative 1, so this is actually negative 15 plus 14i minus 8. So we have negative 23 plus 14i. And that's going to be your answer. Okay, that's it for that lesson. Try your practice problems and let me know if you have any questions. Thank you.